So now we come on to solving our next problem on similarity. Okay, let's understand how do we apply the concepts of similarity to solve this problem. So this problem appeared in CAT 2005. Okay, let's understand what is the problem saying. Consider the triangle ABC as shown in the figure. So this is a triangle ABC as you can see in the figure, where BC is 12, DB is 9 and CD is 6. Okay, so I have the length of these three sides, and also being told that an angle BCD, okay, so this is angle BCD is equal to angle BAC. So what do I understand? BCD means this angle, this blue one, is equals to BAC, this blue one. Okay, so these two blue angles are equal to each other. Okay, that is also given. What is the ratio of the perimeter of triangle ADC to that of the triangle BDC? Okay, so they are asking me what is the perimeter of this yellow triangle ADC to this green triangle, which is BDC. So for that, all that I need are the three sides of this triangle. I know the three sides of triangle BDC, 9, 6 and then 12. So I know the perimeter of BDC already. But I need AC and AD to find out perimeter of triangle ADC. Okay, so that is my concern here right now. How can I find out AD and AC? So I start thinking now. So first I'm thinking which two triangles. I know now I have to apply the concept of similarity because one of the angle is given to be as equal and I need to find out sides. Right? The best way to do that is by the means of similarity. So I'm not thinking of anything else right now. So when I come here, I'm thinking which two triangles are proved to be as similar. Okay, that is the first concern that I have in this case. So let's start thinking now. So first I'm thinking of, see, this angle is given to me as equal to this angle, okay, which is these two blue angles are equal, which I already know it. Okay, what if I take this angle right now, which is angle B, which will be a common angle to which two triangles? To which two triangles? Let's understand this. DBC, this is one triangle, and the entire triangle ABC, they will be similar. Why? Because angle A is equal to angle C. Okay, one of the angle is equal. At the same time, B is in common angle. So I prove that triangle BDC is similar to ABC. Okay, so understand this. BDC is only green, and ABC is, if I have to paint this would be this entire yellow. Okay, so the green part is being compared with this entire yellow, not just the part of the yellow at the top. Okay, so this is a full triangle that I'm talking about. And when you take these two triangles, so understand now, these two angles are equal already. Yes. Okay, and this is a common angle. So two angles are equal in these two triangles, which means these two triangles are similar. That is what I prove it here right now. Okay, so I'll put this as green so that you are able to differentiate between the two. So green and the yellow plus green, that is what we are talking about. So what will be the third angle that will be equal here now? If I'm taking BDC, this would be my third angle. Let me put this as red. Okay, this is the red. And if I'm taking this is your BDC, and if you're taking this A, this will be the third angle. This red will be equal to this red. Right? Okay, because this green is being compared with the big ABC. This three angles would be equal now. Two angles I made them as equal, so third will automatically become equal. So I know everything now. Now it's about writing the ratio of their sides. Okay, what will be the ratio of their sides? Let's write everything. So I'm first thinking of the outer triangle ABC. So in outer triangle ABC, what is opposite to black? Opposite to black is AC. So let's write it here. Let's put this as AC. This will be your AC. Okay, upon what is opposite to black angle now? 6. So AC upon 6 is equals to, let's take now this blue. Okay, what is opposite to blue in the big one? That is 12. So let's write this as 12. What is opposite to blue in this small one? Which is this. So that is 9, right? So I'll write this as 9. And now the only thing that is remaining is the red. So what is opposite to the red one? Check this one. Opposite to the red one in the bigger. We always are looking at the bigger triangle first. So opposite to red one is this, which is AB. Okay, so let's write this as AB. Okay, and opposite to red one in this small triangle is nothing but 12. Okay, this side. So I will write this as 12. And you are done. You can find out AB and AC from this. You will know the answer of the perimeter of these two triangles. Okay, so let's just find it out now. So if I just solve this, let's first take this part. Okay, AC upon 6 is equals to 12 upon 9. So what is AC? 3 2s are 6, 3 3s are 9, and 3 1s are 3 4s are 12. AC is equals to 4 into 2, 8. So I get AC as 8, which means this side is equals to 8. Okay, that is something that I know about it. What else now? I can take the next, which is AB. Okay, so I'll write it here. That is 12 by 9 is equals to AB by 12. Okay, that is what I know about it. So again, just solve this. 3 3s are 9, 3 4s are 12, and 3 1s are 3 4s are 4 into 4. AB turns out to be as 16. So that is also something that I know about. Now, if AB is 16, what do I know? This is 9. Okay, this entire AB, this length is equals to 16. Okay, out of that, BD is 9. So this remaining AD becomes equal to what? This becomes equal to 7 because the entire length is 16. So now I know everything. What is being asked to me now? Perimeter of triangle ADC. So ADC, what is the perimeter? 8 plus 7 plus 6, which is equal to what? 14 plus 7, 21. And what is the perimeter then of the triangle BDC, which I already knew. That was already there in the problem. So BDC is what? That is equal to this. BD 9 plus this 6, which is 15, plus 12. So 17, 27. So this is equals to 27. And if you just cancel this, this is what? 3 7s are 21, 3 9s are 27. 7 is to 9. Option number A is your answer to this question. Okay, so very simple question where you just have to understand what is being given. One of the angle was already given to be as equal. One was the common angle. Now you have to pick up which two triangles you will prove to be as similar to reach on to the answer to the question which is being asked here. So now we come on to solving the next type of problem, which is on heights and distances. So we started with triangle feasibility. We went on to equating area to find out area or length, which was our type 2. Then we came on to the type of exterior angle. Then we came on to the type of similarity. And now we see the type of problem which is based on the concept of heights and distances. So if you open many booklet or the reference book for CAT, you will find this as a chapter, the separate chapter only on this called the heights and distances. Okay, but you don't need a chapter. It's just a concept which is being taken from lines and triangles. Okay, so we'll solve it here only and we'll understand what is there in this chapter. What is it like you're supposed to know to solve problems on this chapter? So for that you need to know just two things. Okay, that is two types of triangles. One is a 45 45 90 triangle and another is a 30 60 90 triangle. That's it. You need to know what is the ratio of their sides always. If you know that, you can solve all the problems. Okay, because they will not ask you any other triangle because they don't give you the logarithmic table there to find out anything else. They will always ask you, pick up any paper of CAT which we are taking here now, 1990 to 2021. All the problems on heights and distances has to include these two triangles. Okay, 45 45 90 and 30 60 90. Okay, so let's understand both these triangles, what are their properties, and let's apply these properties to solve the problems which are being given to us. So before I take this problem on heights and distances which appeared in CAT 2003, let me just give you a basic of this. Okay, as we always do in all the types that we have seen till now, we first understand the basic which is required for us to solve all the problems and then we solve the problems. Okay, so let's see the basics here. So if I make a triangle, let's say this is the triangle that I make. Okay, what are the sides of this triangle? I don't know, but I know the angles. So one of the angle is 30, one is 60, and the other one is 90. Okay, so it doesn't look like a 30, 60, 90. So let's make a right triangle which will better look like a 30, 60, 90 triangle. So I make a triangle which is like this. Okay, what is this angle equal to? 90. What is this angle equal to? 60. And what is this angle equal to? 30. Okay, now what are you supposed to know? The ratio of their side. The ratio of their side is always 1 is to 2 is to root 3. Okay, memorize this. This will be very much helpful to solve many problems in geometry. Okay, just not height and distances. I think we have applied such property in the previous problem that we have solved. Okay, what is the meaning of ratio? You don't know the value. The ratio of the sides will always be 1 is to 2 is to root 3. Okay, from that you cannot say the value. If I multiply this by 2, this will become 2 is to 4 is to 2 root 3. I don't know what are the values. If I multiply this by 3, then it will become 3 is to 6 is to 3 root 3. I don't know the values, but I surely know the ratio. Okay, which will help me to solve a lot of problems in heights and distances. Now there is one more thing that you're supposed to know apart from this ratio. Which side is of what length when it comes to ratio? So for this, you don't need to memorize. That's logic. The side opposite to the highest angle will be the longest side. So more the angle, larger the length of side. Less the angle, shorter the length of side. So side opposite to 90 kya hoga? That will be the largest side, right? Because this is the biggest angle, the largest angle is 90. So side opposite to 90 will be the largest side. So out of 1, 2 and root 3, which is the largest number? 2. Right? Because square root of 3 is 1.73. Okay. So 2 is the largest number here. So side opposite to 90 would be 2. Side opposite to 60 would be what? The second largest. Which is the second largest here? Root 3. So side opposite to 60 would be root 3. And side opposite to 30 would be what? The least, which is 1. The least number here is 1. So side opposite to 30 would be 1. Okay, as I said, no need to memorize this. 90 is the biggest angle. So उसके opposite जो side होगा वो largest होगा. So 1, 2, root 3 में से largest कौन सा है? 2. So 90 के opposite होगा 2. Second largest कौन सा है? Out of 1, 2 and root 3? Root 3. So 60 के opposite क्या होगा? Root 3. 30 के opposite होगा 1. Okay, that is what you are supposed to know. And second triangle that you need to understand here is 45, 45, 90 triangle. So again, it will be a right angle triangle. So I'll draw a right angle triangle here like this, where one of the angle is 90. So let's put one of the angle as 90 and the other two are 45 degree. So this is 45 degree and this is also 45 degree. So you can see that it's an isosceles triangle. Okay, so what is the ratio of their side? 1 is to 1 is to root 2. That is the ratio of their side. So if I say this side is 1, what will be one side? The two sides which are equal will be 1. So this is 1, side opposite to 45. This is 1, side opposite to 45. Side opposite to 90 will obviously be your root 2. Okay, again from this you cannot see me the value. You know the ratio. A value can be determined when you know what is this ratio multiplied by. So if it is multiplied by 5, this becomes 5, this becomes 5 and this becomes 5 root 2. Right, so you know the ratio. From this you can determine the value. Okay, let me help you understand this even better. So I'm taking a triangle here now. The two triangles that you can see on the screen here now, one is a 45, 45, 90 and the other one is a 30, 60, 90 triangle. Okay, check this 45, 45, 90 triangle. One of the side is 7, the other side is 7 and the side opposite to 90 is nothing but 10. Okay, which is nothing but square root of 2. Square root of 2 is 1.41. So 7 into 1.41 will give you that, which is the side opposite to a 90-degree angle. Now you can change this. Okay, you can change this to any which ways. Pick up the length of the side as anything. See, again I'll make it as 45, 45, 90. Okay, I hope you can, it will not exactly go, but I hope you can understand this. If I make it as 45, 45, 90 again, what will happen? The two sides will be same. See, this is becoming 10.6, 10.6. Okay, this will, as I make this as 45. If I make this as 45, this both, check this out now, but this is changing now. So I hope you are able to understand this. Okay, if I make this one of them as 90, see 10.8, 10.8, both will be. And the side opposite to 90-degree will be 10.8 into 1.41. 1 is to 1 is to root 2. Root 2 is 1.41. So whatever is your side, multiply that by 1.41 to get the side that is opposite to a 90-degree angle. It will always be like that. Okay, it doesn't matter what is the length of the side. I know the ratio. It will always be 1 is to 1 is to root 2. So if I know one of the side, that is 10.8, I know what is the hypotenuse then. That is how it is. Similarly, that is the case with the 30, 60, 90 triangle. As you can see, what are the three sides that you can see here? One is angle is 30, one is 90, one is 60. Okay, as you can clearly see it here on the screen. One of the side is 4.6, 7.9 and 9.2. As you can check it, write this down. The ratio of these three sides will be 1 is to 2 is to root 3. Okay, which is the side that is 2? That is always opposite to 90. So check, side opposite to 90 is 9.2. Which is the side that is one side opposite to 30? That is 4.6. 4.6 into 2 is 9.2. See, here only you got the ratio is 1 is to 2. And the next is root 3. Root 3 is what? 1.73. So 4.6 into 1.73 will give you 7.9. So you know that the ratio is 1 is to 2 is to root 3 always. If I change the length, as I did it in 45, 45, 90, if I change the length, doesn't matter. And if I keep the angle as same, okay, to keep the angle as same, I will have to put this down. So let's make this as 60 here. Okay, I made this as 60. Now this is again 90 and this is 30. Yeah, almost approximately there. Okay, not, just avoid that 0.01. So as you can check it, one is 6.1, one is 10.1. If I make this is side opposite to 30 now. Okay, I made this one as 60. So side opposite to 30 is what? 6. Double of that is what? 12. Okay, that is a side opposite to 90. Check it there, 11.7, because this is 89, not 90. If you make this as 90, you will get the answer as, okay, that is 12. Okay, it will increase. So 6, 12, 1 is to 2. And the next will be root 3. So 6 into 1.73. Okay, 0.7 into 6 is what? 4. So 6 plus 4, it will be approximately 10. That is what you are getting. That is what I know from this. If the angles are 30, 60, 90, the ratio of the side of that 30, 60, 90 triangle will always be 1 is to 2 is to root 3. You know 1 is opposite to 30. 2 is opposite to 90. And root 3 is opposite to 60. Right? And I gave you the trick how to remember this as well. The larger the angle, the larger the side. That's how simple it is. Okay, so from this you know the ratio. If you know one of the side now, if I know that one of the side is 10.1, okay, which is a side opposite to 60, I know what are the three sides of the triangle. If I know that the triangle is a 30, 60, 90 triangle, because I know the ratio. Similarly, you will do this with 45, 45, 90 triangle. If I know one of the side that is opposite to 90 is 15.3, I know that the ratio is 1 is to 1 is to root 2. So root 2 is 15.3. So what is 1? Okay, that's how you can find out the answer to this 30, 60, 90 and 45, 45, 90 triangle. So remember this ratio. It will be very much helpful for us to solve a lot of problems. Okay, generally we memorize the ratio but don't understand as to how will you get the sides from the ratio. But I hope you are able to visualize now. how to get side. If one of the side is given and you know the ratio, how do you get the other sides? As we solve the problem, you will understand this better, but make sure you visualize this so that you are in a right state to solve problems on the 30 60 90 and 45 45 90